Okay, I am going to help you with work assignment number 4, which is on esters and carboxylic acids, naming as well as chemical reactions. So, go to your cheat sheet and you see that carboxylic acids have this basic structure. The ending of a carboxylic acid, that is an aliphatic carboxylic acid, ends in enoic acid. Here's an example. This is ethanoic acid, 2 carbons, eth. Okay, aliphatic esters, they end in anoate. And you also have to include the alcohol portion of the ester. So in this case, this structure is methyl ethanoate. Now, the aromatic carboxylic acids and esters are a little bit different. Aromatic carboxylic acids end in benzoic acid, and aromatic esters end in benzoate. So once again, you have to identify the alcohol involved, and in this case, it's methyl. So this is going to be methyl benzoate. So when I do these problems, particularly with esters, so this is an ester, how do I know? Because there's a carbonyl and an ether. So an ether and a carbonyl is an ester. So I always like to circle the alcohol portion of the ester and the acidic portion of the ester. So the alcohol portion gets named methyl, and that goes at the beginning. And the acidic portion of this particular ester is going to be 1, 2, 3, 4 butanoate. Okay, so this is going to be methyl butanoate. So once again, I like to circle the acid portion and the alcohol portion. So the acid portion is going to be benzoate. And the alcohol portion is going to be 2 carbons, ethyl. So this is going to be ethyl benzoate, and you leave a space, benzoate. Okay, so here's a carboxylic acid. It's got a carboxylic acid functional group, an alkane functional group, and a hydroxy functional group. And if you look at your cheat sheet, you know the highest priority is going to be carboxylate. So the parent name of this molecule is going to be named after a carboxylic acid, and it's going to include these substituent groups. So carboxylic acids end in enoic acid. And you count the longest chain, so that's going to be 1, 2, 3, 4, 5. 5, so this is going to be a pentanoic acid, and you have 2 substituent groups. This is going to be a 2-methyl and this is going to be a 5-hydroxy. So H comes before M, so this is going to be 5-hydroxy 2-methyl pentanoic acid. 5-hydroxy 2-methyl pentanoic acid. Okay, so here's a carboxylic acid, but it has a sodium attached to it. So this is the sodium salt of a carboxylic acid. So it actually gets named as an ester. So this is the front end of the molecule, and this is the parent name of the molecule. So this front end is going to be sodium. And this back end, 1, 2, 3, 4, it's a butanoate. So this is the acid part, and this is the front end. So this is going to be called sodium space butanoate. Okay, so here's an ester. How do I know? Because it has a carbonyl and it also has an ether. But as you can see, it's drawn backwards from the way this is drawn. So what is going to be helpful is to circle the acid portion and circle the alcohol portion. The alcohol portion is going to be ethyl, 1, 2 carbons. And the acid portion is going to be named after 1, 2, 3 carbons. So that's going to be propanoate. So this is ethyl propanoate. Propanoate because it's 3. 1, 2, 3. Okay, here is a carboxylic acid with a substituent group. So the carboxylic acid portion is going to be named as anoic acid is going to be the back end. There are 1, 2, 3, 4, 1, 2, 3. So the longest carbon is 1, 2, 3, 4. So that's going to be bute. So this is a butanoic acid. We have to name this substituent group carbon 1, 2, 3, 4, carbon 2. So this group is going to be 2-methyl. And so this is named 2-methyl butanoic acid. 2-methyl butanoic acid. Okay, here, once again, we have the sodium salt of a carboxylic acid. So this gets named as an ester. So this is the acid portion of the ester. And there are 1, 2, 3, 4, 5 with no substituent groups. So this is pentanoic. Sorry. This is pentanoate. since it's an ester. Pentanoate is this part, and this part is sodium. So this gets named as sodium pentanoate. Pentanoate, sodium pentanoate. Okay, let's go over these reactions. So this is an acid hydrolysis of an ester. So you can say that acid hydrolysis of an ester. How do I know it's an ester? Because it has a carbonyl and an ether group. This is the carbonyl, this is the ether group. That combination is an ester. So you should have a flashcard on this. It's acid hydrolysis. HCl is an acid. Water is what's used for the hydrolysis. So we're going to break this up into its alcohol component and its acid component. And since it's hydrolyzed by acid, this oxygen gets protonated on the acid side as the alcohol side. So this is going to look like this. CH3, CH2, CH2. Here's the acid portion. And then this oxygen gets protonated with a hydrogen because it's under acid conditions. And the alcohol is going to be HOCH. So literally an H goes on there as the alcohol, and an H goes on there as the acid. So that H goes on twice. Okay, so here is a carboxylic acid and an alcohol in the presence of an acid. So we're going to synthesize an ester. And quite literally, we're going to take this and bond it to that oxygen. We're going to get rid of that, and we're going to get rid of that as water. So we simply rewrite this CH3, CH2, CH2, and here's the carbonyl. Here's the oxygen, and we're going to stick that onto it. So that's going to be CH2, CH3 plus water. Okay, so quite literally, this carbon, which is right there, is bonded to this oxygen, which is right there. And then we remove this H and this OH as water. Okay, so sodium hydroxide is a base. So we are going to do a base hydrolysis of an ester. It's very similar to the acid hydrolysis of an ester. The only difference is that the product, the acid product, is going to be the sodium salt of a carboxylic acid. Okay, so once again, we can circle, that's going to be the alcohol portion. This is going to be the acid portion. And as you can see, the direction is different. Here the acid comes first and the alcohol comes second. Here the alcohol comes first and the acid comes second. So just make sure you know that this is the acid part of it and that this is the alcohol part of it. So we just rewrite that as the acid. So I'm just going to literally redraw this. See how I've redrawn the acid portion? But since it's hydrolyzed by a base, it's going to be the sodium salt of the acid. So this gets a negative, and this gets a positive, the sodium salt of the acid. Here is the alcohol, and so it's going to be CH3, CH2, OH, which is ethanol. So in terms of sodium hydroxide, base hydrolysis of an ester, the alcohol gets the H, and the acid gets the sodium. Okay? All right. So here is an ester, a carbonyl, and an ether, which is an ester. It's going to be acid hydrolyzed. So this is the acid part. And this is the alcohol part. Okay, and in each case, we're going to attach a hydrogen to the acid part, and we're going to attach a hydrogen to the alcohol part. And since it's acid hydrolyzed, the acid, which is benzoic acid, the OH, the O, gets protonated. So this is benzoic acid. And an H is attached to the alcohol, so that's going to be H, O, CH2, CH3. So this is ethanol. So that H goes there, and this H goes there in the alcohol. Okay, so this is a carboxylic acid, and we're going to neutralize it with sodium hydroxide. Okay, so essentially we just rewrite this thing, and a sodium is going to be associated with that oxygen, and this hydrogen is going to end up with this OH as water. So here we go. We just basically rewrite this CH3, CH2, CH2, C, double bond O, the carbonyl, and O, negative, sodium, positive, plus water, H2O. So this is the sodium salt of 1,2,3,4 butanoic acid, the sodium salt of butanoic acid, and water.